All right, let's talk about Java. If you're just starting out, you've probably heard the word method a bunch. But what is it really? Well, think of methods as the Lego bricks of your code. They're the most basic, most important pieces you'll use. We're going to break them down one by one so you can start building some really clean, really powerful programs right away.
So here's our game plan for today. First, we'll meet the Java method, what it is, and why it's so important. Then, we'll look at how to make our methods do a lot more, giving them some real power. After that, we'll get into a super important rule, the difference between a class and an object. And to wrap it all up, we'll put all those pieces together and see how they create a real working program. Let's do it!
Okay, let's start at square one. What in the world is a method? And more importantly, why is it one of the very first things you absolutely have to get your head around in Java?
When you boil it all down, a method is just a block of code that you give a name to, and it does one specific thing. I love this robot analogy. Imagine you tell a robot, make coffee. It knows exactly what steps to follow. A method is just like that. It's a reusable command you can give your program whenever you need it.
So you might be thinking, why even bother? Can't I just write all my code in one big chunk? Well, you could, but you'd be making your life way harder. First off, reusability. You write some logic once and you can call it 100 times without rewriting it. Huge time saver. Second, organization. Methods turn a potential spaghetti monster of code into neat, tidy, and understandable chunks. And that makes the third point possible. When something inevitably breaks, it's so much easier to find and fix a bug inside a small, focused method than digging through 1,000 lines of code. Okay, so we know what a method is, but right now it's just a basic command. Let's see how we can start giving these methods different abilities, making them way more powerful and flexible for whatever we need them to do.
We'll start with the simplest form of method you can write. This one is pretty straightforward. It doesn't take any information in, and it doesn't give any answers back. Its one and only job is to just do something when you tell it to.
And here's what that looks like. We've named this one Say Hello. Now, see those empty parentheses? That's our clue that this method doesn't need any outside info to do its job. And that word void? That's just a fancy way of saying it's not going to send an answer back. So when you call this method, it does one thing and one thing only. It prints that greeting. It's basically a fire and forget kind of command.
The real key with these simple methods is to keep them focused. They're perfect when you just need something to happen and you don't need a calculation or a result back. And a bit of pro advice, give it a name that's a clear action, like open browser or save file. Anyone reading your code should know exactly what it does. And please, don't try to make one method do 10 different things. Keep it simple. One method, one job.
Okay, that's cool, but what if we want our little robot command to be a bit more intelligent? This is where parameters come into play. They are how we pass information into a method, which makes it incredibly more useful. The magic is happening right inside those parentheses. String name. That's a parameter. Think of it like a mail slot. It's a placeholder waiting for a piece of information. So now, when we call this method, we can pass in a value, like greet by name Ava. The method takes that name and uses it to print a custom greeting. Just like that, our method went from doing one static thing to being super flexible. And this really gets to the heart of why parameters are awesome. You use them when the basic action is the same, but the little details change each time. Now, that don't on the screen, it is so important. If you find yourself writing something like system.out.println hello Ava directly inside a method, that's a huge red flag that you should probably be using a parameter instead.
So far, our methods have just been performing actions. But what if we need them to figure something out and give us the answer? You know, like a calculator. For that, we need a method that has a return type.
Okay, a couple of new things here. First, notice that instead of void, we now have the word int. This is a promise. This method is officially promising us, hey, when I'm done, I swear I will give you an integer value back. And second, look at that last line, return a plus b. This is the method keeping its promise. It does the math, gets the result, and then sends that result back to wherever it was called from.
So here's the golden rule, the thing you have to remember. If your method isn't void, it's making a promise. And that means it must, absolutely must, have a return keyword inside it somewhere. And of course, whatever you're returning has to match the type you promised. You can't promise an integer and then try to return a sentence. Java won't let you.
All right, now we need to talk about a really crucial idea in Java, one that can be a little tricky at first. It's about where a method actually lives. Does it belong to the general blueprint of a thing, the class, or does it belong to a specific individual thing you've created from that blueprint, an object? This brings us to the all-important difference between static and non-static. This chart lays it out perfectly. On the left, you've got static methods. They belong to the class itself, the blueprint. Think of them as general tools that anybody can use. A great example is math.max. You don't need to create a special math object to use it. You just call it directly on the math class. But on the right, you have non-static methods. These belong to a specific object that you create. They're actions that one particular thing can do. You can't just tell the world to start. You have to tell a specific car to start, like mycar.start.
Phew! Okay, we've seen all the individual Lego bricks. Now for the really fun part. Let's see how they all snap together to create a flexible, powerful, and complete program. First, let's talk about a really cool technique called method overloading. This lets you have multiple methods that share the exact same name, as long as they have different parameters. So here, we have 3 different flavors of the greet method, and Java is smart. Depending on whether you give it nothing, or just a name and an age, it automatically picks the correct version to run. It's an amazing way to make your code more flexible. And this right here brings it all home. Check out what's happening inside our main method. The very first line calls robotactions.showInfo. We're calling that static method directly on the class name, see? No robot object needed. But for all the other methods, we first have to create a new instance, our very own specific robot. And only then can we call the non-static methods on it, like robot.start, robot.move, and robot.add. This is that whole class versus object rule playing out in a real program.
And there you have it. We've broken down methods into all their core parts, from the simplest commands to these flexible tools that can take in data and give you answers back. They really are the foundation for writing good, clean, powerful code. So the only question left is, now that you have all the building blocks, what are you going to build first?